Hi everybody, this is the second video from day one of 12.2. It is dealing with the rational zeros theorem. In some textbooks or worksheets, they call it the rational root theorem. But like I said in the last video, roots, solutions, zeros, x-intercepts, it's all saying the same thing. It's just a matter of if the polynomial is given in function form or 0 equals just an equation form. But what the theorem states is this. Let f of x be a simplified polynomial with integer coefficients. Oh, hold on. Sorry. Let f of x be a simplified polynomial with integer coefficients. If f of x equals 0, has a rational 0, p over q. Now remember, rational number is just any number that can be written as a fraction, okay, p over q, where p and q are both integers, that is in lowest terms. Then p must be an integer coefficient of the constant term, and q must be an integer coefficient of the leading coefficient of f of x. So if we have a rational 0 that we're calling p over q, the numerator of that 0 we are saying is an integer coefficient of the constant term, and the denominator of that rational 0, the q value, has to be an integer coefficient of the leading coefficient. Okay? So here we go. Let f of x equals 2x cubed plus 7x squared minus 14x plus 5. Find all rational zeros of f of x. So as I said, if there is a rational 0, it is going to be some p over q, where p is an integer factor of my constant term, and q is an integer factor of my leading coefficient. All right? So the first thing I need to do is find what the possible rational zeros are. Okay? So I need to list every single possible p over q, where p is an integer coefficient integer factor of the constant, and q is an integer factor of the leading coefficient. I need to list every single one of them. So if I'm thinking about my p's, the p's, I want all factors of 5. They're integers. I could have plus or minus 1 or plus or minus 5. Now the sign here really doesn't matter, because in order to get positive 5, I could have positive 1 times positive 5 or negative 1 times negative 5. I need all of those positive and also negative integers there. So my p's that I'm listing out is plus or minus 1, plus or minus 5. All of my possible q values are going to be all of my factors of my leading coefficient. So the factors of 2 are 1 and 2. So I need plus or minus 1 and plus or minus 2. So the reason I'm listing these two out is because I need to find what my p over q's could possibly be. My p over q is going to be every single one of these divided by every single one of these. So 1 over 1, 1 over 2. So plus or minus 1 over 1, plus or minus 1 over 2. And then I need 5 over 1 and 5 over 2. Plus or minus 5, and plus or minus 5 over 2. So I have 1, 2, 3, 4, 5, 6, 7, 8 possible rational zeros. Okay? So it could be any of these. These are my possibles. Step 2, I need to check to see which p over q's, when I take f of p over q, when is that going to equal 0? Okay? Because by definition, it's a 0 of a function if, when I plug it into the function and solve for and simplify it out, I'm going to get an answer of 0. So what I will be doing now is I'm going to need to find what is f of 1, what is f of negative 1, what is f of 1/2, what is f of negative 1/2, what's f of 5, what's f of negative 5, what's f of 5/2, and what's f of negative 5/2. I need to find all of those. And all I'm trying to do is figure out which of those 8 will give me an answer of 0. When that's the case, they are zeros of my function. Okay, now I can take all of these numbers, like 1, I can start with 1, and I can go ahead and plug 1 in for all the x values to evaluate what that particular answer is. So I'll go ahead and do that here. It's 2 times 1 cubed plus 7 times 1 squared minus 14 times 1 plus 5. This is going to be 2 plus 7 minus 14 plus 5. That's 9. Minus 14 is negative 5 plus 5. That gives me an answer of 0. So f of 1 equals 0. I want you to notice how annoying this is going to start getting. I just noticed here there should be negative 5. Or no, I'm sorry. That was it. I want you to notice how annoying this is going to get. Right here, when I have 1/2. I'm going to have 1/2 cubed times 2, 1/2 squared times 7. I'm going to start getting into nasty fractions. So what I suggest you do is use your TI-84, okay? Or you can use the TI Smart View that's right on your laptop. If you just go into y equals the top left button and you just type in the function that you were given, I did that right here, okay? If you notice up here, right above where the trace button is this blue calc button. If I hit second calc, and the very first option here is value, if I hit enter there, notice at the bottom that this x equals is blinking. I can put any number I want in for x, and it will spit back what my answer for y is. So I already did 1 by hand, but just notice, if I just say x equals 1, enter, boom, it tells me that y equals 0. Okay, if I do it again, second calc, let's try -1 now. If I plug in -1 and hit enter, it gives me a y value of 24. All I care about is if my answer is 0. Okay, so f of 1 was equal to 0. F of -1, I got 24. I don't even really need you to put that it's equal to 24. I just need you to put that it doesn't equal 0. It's only a matter of, does it equal 0 or does it not equal 0? Okay, now I'm going to do second calc. I want value of 1/2. Enter. Notice the y value is equal to 0. Awesome. So f of 1/2, that equals 0. If I try f of the second calc value of -1/2, 13.5. Again, it doesn't matter to me what it is. I just know that it's not equal to 0. F of 5, second calculate, second calc for 1. I'm going to type in x equals 5, 360. Okay, great. That's not equal to 0. That's all I care about. And then -5, if I go second calc value -5, enter, boom, I get a y value of 0. Okay, so notice I got f of 1 was equal to 0, f of 1/2 was equal to 0, and f of -5 was equal to 0. So in this case, that tells me that my rational zeros are 1, -5, and positive 1/2. I found 3 of them. Okay. Now I'm just going to give you a little heads up into what's coming over the next several days. Whatever this leading coefficient is, I'm sorry, this leading degree, this is a cubic. Whatever the degree is, you are not going to get any zeros that are more than whatever the degree is. Okay, and I'm going to go into specifics with that in a couple days, but with a third degree polynomial, you will get no more than 3 zeros. So, for example, if I had like 13 of these that I had to check to see which ones equal 0 and which ones don't equal 0, the second you hit whatever the degree of the polynomial is, you can stop. There can be at most that many zeros. Okay? So here the rational zeros are 1, -5, and 1/2. Now let's say I went a step further and said, hey, I don't necessarily want the zeros. I want you to write the factors of that particular polynomial function. after I found the zeros, I could write, the 0 of 1 will leave me a factor of x minus 1. The 0 of negative 5 leaves me with a factor of x plus 5, and 1/2 will leave me with a factor of 2x minus 1. Okay? So factors are these. Now, I didn't necessarily ask you for that, but you could see that down the line. All right, so my rational zeros, 1, negative 5, and 1/2. Next one, find all rational zeros of f of x equals x squared minus 3. First, I got to find all my possibles. P-values, the factors of my constant, plus or minus 1, plus or minus 3. My Q values, my leading coefficient is 1, so I just have plus or minus 1. Now I'm listing P over Q's. All of them will be plus or minus 1 over 1 for that P over Q, plus or minus 3 over 1 for that P over Q. So my possibles, plus or minus 1 and plus or minus 3. I now need to find what is f of 1, what is f of negative 1, what is f of 3, and what is f negative 3. Now, I'll just save you the suspense. F of 1 is negative 2, so is f of negative 1. F of 3 is 6, and so is f of negative 3. So notice, I just did all of my P over Q's. I evaluated all of them, and not one of them gave me an answer of 0. All that tells me is that there are no rational zeros. Now, what I need to say here, triple star, okay? This just means that the zeros of this function are either irrational or imaginary. I don't want you to think that if there are no rational zeros, that means there aren't any zeros. I can still get solutions and zeros of a function that aren't necessarily rational. The only thing this P over Q test is doing for you, this theorem, is finding the rational ones that you can write as an integer divided by another integer fraction. Okay, so all this means is that the zeros that we found here aren't going to be rational. And if I go ahead and solve that, I mean, we should know how to do this. I had f of x equals x squared minus 3. If I set this equal to 0 and say 0 equals x squared minus 3, I can easily solve this equation by just adding 3 to both sides to give me 3 equals x squared. And then when I solve by taking the square root of both sides, I'm going to get x equals, remember when you take the square root of both sides, you need plus or minus the square root of 3. So my two zeros of this function, the first one would be positive root 3, the other one would be negative root 3. So they both exist. There's as many as there are degree of the function. They just didn't have, they happen to, when you find them, neither of them are rational. Okay? So you can still find all zeros. It's just you can't use this particular rational zeros theorem to find any of them except for the rational zeros. All right? All right, everybody.